Okay, we are going to move on to talk about square roots and cube roots. They are exactly what they sound like. Square roots are talking about anything in the shape of a square. Cube roots are talking about the measurements of anything on a cube. So what these are, square roots and cube roots, think of the word root. Root means you're getting to the bottom of something, if you can think of it that way. So in other words, when we do these, it's almost in a sense like working backwards. So instead of always multiplying or dividing, we're going to take what's called the square root or the cube root. So we're going to find the measurements of the original shape, I guess is a way I could say that. It's really not too complicated, so I don't want to overcomplicate it. So I'm just going to jump right into these examples. These exact examples will be on your assignment for you so that you can look at them and watch the video. And when you're done watching the video, you can have them right there for you to reference back to. Okay, so example 1, evaluating cube roots. So that just means we're going to be working with a cube. So Leah is building a birdhouse for purple martins, birds that prefer cube-shaped birdhouses. What are the dimensions of each square piece of wood? So in other words, we want to know what are the dimensions of each side. And what are the dimensions that Leah needs to build the 216 cubic inch birdhouse? So I know that's a little bit kind of blurry there. Let me see if I can zoom in. There we go. But let me see if I can draw there. Obviously, of that whole paragraph, this was the only piece of information that had some numbers with it. So that's pretty important. So we know that the entire cube is going to be 216 cubic inches. All right, let me scroll down. All right, so here we have a better picture of it, of just a regular cube. So the birdhouse is up in the picture, but it might be a little bit easier to visualize just a regular old cube. And we know that the volume, so if you didn't know, volume is length times width times height. Well, when we're talking about a cube, the cool thing about a cube is that it's just a bunch of squares put together. So what do we know about squares? They all have the same side lengths. That's what makes a square so unique and special. So if we want to figure out, so let's start with this. 216 inches cubed. Notice that cubed means a number 3. Notice that we're multiplying 3 things, length times width times height. So if we want to kind of work in the reverse to find what the perfect cube is, we need to take what's called the cubed root. So let me jot a couple things down for you before we do that math. No, I don't want yellow, it's not going to stick out. Okay, so here's what we know so far. It's going to be 216 inches cubed. And instead of length times width times height, since they're all S's, do you see where they're labeled on the picture? We're just going to say it's side times side times side. Still the same thing. Well, when you have 3 of the same thing being multiplied, we can write that as what's called S cubed because there were 3 S's. It's the same as saying, let me go over to the side for a second, then I'll probably erase it. It's the same as saying 4 times 4. That's the same as 4 squared because there's 2 of them. So they mean the same thing. So that's how we can simplify things and put them together. So let me erase that so it's not in our way. Okay, let's look at this small note first. It says a number that is a cube of an integer. Integer is just a big fancy word for a whole number, positive or negative or 0. A number that is a cube of an integer is called a perfect cube. And I like that they use the word perfect because that's kind of how I describe it as well. So what that means is whenever we get the answer, it's not going to be some crazy number like 1.25856 whatever. Like, or it's not going to be a fraction. It's going to be just a simple whole number. So I call it a perfect number, or it's called a perfect cube. Okay, and then kind of how I mentioned already, if we want to find the value of s, in other words, if we want to find what the length of each side is, we have to find what's called the cube root. Of 216. And then I added this extra note in with these notes. And I'm going to show you a calculator that works, and I will also attach the link for this specific calculator while you're at home. This is the symbol for a cubed root. The little check mark symbol, which is called a radical sign, with a 3, a little tiny 3 on the outside. That's very important that you can distinguish between that and the square root, which we'll talk about. Cubed root will always, always, always have that little 3 on the outside. Okay, so let's try it. Let's break down what all we talked about so far, because again, it's really not that hard. I just want to make sure I teach you all of the details that go along with it. So here's what it looks like. We're going to say, what is the cubed root of 216? So what we need to do is we need to find one single number. It can't be several, like it can't be 2 times 5 times 10. Those are all different numbers. It has to be one number that you can multiply by itself 3 times. So for example, 2 times 2 times 2. We need to find one number that's going to reach 216. There are several ways to be able to break this down. For the sake of this video, normally in class I'd give you plenty of time to brainstorm, but I don't want to make you have to wait too long on a video. This turns into the same as 6 times 6 times 6. So if you would do the math and multiply 6 times 6 times 6, it's going to give you the exact same answer as 216. So here's where we start the grouping process. We can start pulling things out from underneath of that little check mark symbol, the radical, as long as, I'm going to highlight it if it will work for me, as long as there are pairs of 3, or sets of 3, I should say. Well, how many 6s do we have? We have 1, 2, 3. So since we have a set of 3, and we're doing the cubed root, which means 3, that means this is the same as the cubed root of 6 cubed, because remember there's 3 6s, which we can write as 6 cubed. And in the end, what happens is when you have sets of 3, when you're doing the cubed root, or you could think of it this way, these cancel each other out. It turns into just 6. So let me wrap this back around to what this is saying. Remember, the volume is length times width times height, or for a cube, it's side times side times side. So that means that each side is 6 inches, which is what we were looking for here. The dimensions of a square on this cube would mean it's 6 inches by 6 inches. Okay, so again, cube roots, not too tricky. I will show you some more with them, but you're looking to find what single number can you multiply 3 times to get back to the number you started with. And in this case, it was 6. Okay, let's try the try it section. And again, I know some of this got a little kind of blurry. I don't know why, but it did. It says a cube-shaped art sculpture has a volume. Again, volume means a cube, so length times width times height, has a volume of 64 cubic feet. What is the length of each edge, in other words, each side of the cube. And it's already set up for us over here. I'm going to just rewrite the first step above it just because it's kind of wonky, and again, it got blurry. I don't know why. Zoom in a little bit. So I'm just going to rewrite this first step, that's all. So it has the cubed root of 64, because that's what we were told, 64 cubic feet equals the cubed root of what number? What number can we multiply by itself 3 times to get back to 64? Well, in this case, it's 4 times 4 times 4. Which again, when you have all of the same thing, you can squish it together and give it an exponent. And since there were 3 of them, it has a 3. So cubed, 4 cubed. And again, your final step is, since you had 3 number 4s, and you're doing the cubed root, they cancel each other out, and your final answer is just 4. So that means the length of each edge or each side is going to be 4 feet on that cube. So there's cube roots. Okay, now we're going to practice a couple. So square roots. Square roots are exactly the same, except squares only have, if you think about finding like area, it would be length times width. So it's only a 2. All right, so let's try letter A first. Letter A says cubed root of 64. That might seem familiar to you because we just did that. 4 times 4 times 4. Sorry, trying to make sure everything is under that line. And that turns into the same thing as the cubed root of 4 cubed, which eventually equals 4. Okay, so again, that's the one we just did on the last example as well. Here's the one that I want to talk to you about. Notice that on this one, the radical symbol, that little check mark symbol, does not have a 3. That means this is called a square root. Square root means that there's technically, and you can write it if it helps you. You don't have to, and you'll probably rarely ever see it, but that means there's actually a 2 there. That is a terrible 2. Let me try that again. A little bit better. That means there's a 2 there. You just usually don't see it because that's what the symbol means is a square root. So we're going to follow the same exact process to find the square root of 100. So that means we want to find what can you multiply only 2 times to get to 100. And in this case, it would be 10 times 10. Which is the same as 10 squared because there's 2 10s, 10 to the second power. And again, since you had you had a pair of 10, you had 2 number 10s, and you were looking for 2 on the outside, they cancel each other out, and you're left with the number 10. Okay, same thing with square root of 49. Again, notice there's not a 3 there. So it's just going to be square root of 49. And we need to figure out what number multiplied 2 times gives you 49. Hopefully that one comes a little faster for you. That would be 7 times 7. Again, just writing it out so you can see what's happening. So since there's 2 7s, we can call that 7 squared. And I'm going to write it here just so you can see what happens. So again, there's an invisible 2 right there. You can write it if it helps you, but you just won't usually see it. Since we're finding the square root and we had 2 7s underneath, they can be brought to the outside and give you just a number 7. Now this last one does have a cubed root, so we're back to what we talked about at the beginning. So we have cubed root of 8, and for a cubed root, it is extremely important that you make sure your little 3 is on the outside there, or else it's a square root, which makes it completely different. So please make sure your 3 is there. So we have cubed root. Now what number times itself 3 times is going to give you the number 8? In this case, it's going to be 2. 2 times 2 times 2 gives you 8. And again, just breaking it down, so that means it's the same as the cubed root of 2 cubed, which just turns into 2. Simple as that. I'm going to leave the try it section to you, again, for the sake of the video. A lot of them are very similar. Okay, and then lastly, this last part, evaluate square roots to solve problems. So now again, we're going to talk about square roots, a square, not a cube. So it says Sean cuts one sheet of colorful poster paper to cover the bulletin board exactly. What are the dimensions of the poster paper? And we see it over in the locker picture. So it told us the area is 144 inches squared. We're talking about a square. So that's important that we know that information. So that means, since we're talking about a square, I'm going to write it down here in this blank space. I was trying to figure out where I wanted to write it. We're talking about the square root of 144. Well, what number times itself gives you 144? We need 2 of them. That would be 12 times 12. And again, that's the same as 12 squared, which when you take the square root of 12 squared, it's going to give you 12. So that means each side of this board is going to measure 12 inches. And Sean will need to cut a 12 by 12 inch by 12 inch sheet. So again, it's really short and sweet, just like that. Now I am going to show you something in case you need it. I'm going to show you a calculator to use, and I'll attach the link for it as well. I find it best to use the Desmos calculator. It's something you can Google. Just Google Desmos calculator and it will come up. The reason being is because the Desmos calculator gives you the option to use a cubed root. So look over to the left. I can't really draw on it, but look over to the left of my calculator here. You'll see the 3 words. It said sine, but it looks like sin, cos, cosine, and tangent. Look at those 3 words and look right above them. You have the pi symbol, you have the square root symbol, and right in the middle you have a square root symbol with an n. What that means is where that n is, when you tap on it, you can insert a 3 for your cubed root and then type your number. So for example, we did the cubed root of 64 and the answer is 4, which is exactly what we got. We actually did that one twice in the examples. So again, if you need a calculator, I recommend using this one because it allows you to put the cubed root in. So let me clear that. If you just need the square root, so the one we just did together was the square root of 144. So you just tap square root 144, oops, and it will give you 12, which is the answer we got. So you can always double check yourself or test some things out if you're really struggling figuring out which number to use. Okay, let me go back. And again, just for the sake of the video, oops, sorry. I think we're okay to skip over that last try it problem. You can look over it if you would like, but I'm not going to take more time up in the video. So that's the end of the examples. And then right underneath is where you're going to do your practice problems. So here's all your practice. Just front and back sheet is what it would normally be. And you can write on those or type if you need to.